Hey friends, Cristiano speaking over here. So I'd like to record this video in English so I can provide you with an update of the new developments on the Was Blaster Reloaded. Um, so I've sent a few cartridges for reduced number of people. Some of you had issues with the noise and cracking sounds on the board. So that was caused by Yamaha DAC that has super strict requirements uh, on the board for the board, right? So and then if the components have some variations, and depending on those, you can hear those cracking sounds. And the thing is, that Yamaha DAC is super old, and in half of the components, the half of them that I buy, it's we can just throw away because they don't work okay. So I decided to do a major improvement on the board, and he used it. So this is a prototype, of course, right? So it doesn't have any concerns around quality, but it's already super good in terms of quality. And here you see that I'm using with my FPGA MSX. Just if something goes wrong, I can fix it. And I'm using this prototype, and you see the blinking lights over here. It's already with a Bluetooth module, as well as with the open source UDA 1334 DAC board. So that is an open source project from Adafruit. Anybody can actually build those, but those sell very cheaply on AliExpress and other sellers as well as the Bluetooth module. So, and here you see that I also replaced the flash by this flash. So we use old EEPROM on the original project from Gustavo Iarti, and now I'm using a modern flash to host the MIDI waves. So I mean, I still use, so this prototype is using just 512K of memory, but I will be building the cartridges with 1 megabyte. I know we can have more than that, but I still have a lot of those chips around, so I'll be building with those. And here, of course, the Yamaha chip, it's behind here, so I'm gonna show in details in a few, but I would like to show the board working so you guys can feel the the Bluetooth working, as well as the quality of the new dock. So here I have my Bose speaker, right? So it's a wireless one, so it's not connected, and it's already playing. So my MSX, it's playing Amiga trackers, and if I just hit unmute, so you can hear that. So and this is over Bluetooth. It's not connected. And here you see that I do have a proto board over here. So this is just to host a small button, and the way that this Bluetooth module works is it has a button over here to pair new devices, and as soon as you pair new ones, when you turn on your MSX, of course you turn on the circuit, then you need to hit a button, and then it's going to connect to the last device it was connected previously, right? So that's the reason I left the button over here, but I still need to figure out how to surface that button, as well as the LED, because you need that to understand what's going on with the module, as well as the button to pair. So I need to bring all those buttons up to the cartridge, so I'll figure out a way to do that. And here you see that my my board is also connected to my capture card. So if I move to my MSX, you can also hear the music, right? And you see no cracking noise, and I have the maximum volume, so I can, including change the stereo configuration. And so you can just go over here, and then you have the the left and right effects. usually I have like middle term, so that's okay. And so I mean, let me show more details on the board so you can understand. So let me just turn off my MSX, and with care, I'm going to remove it from here. And let me just remove this as well. And you see that I lost Bluetooth connectivity over there. And in here, I have an over camera, so you can see everything. So here's the board, right? So here on the back, you see that I have the Yamaha OPL4. And in here I have just tantalum capacitor and a few capacitors for the main chip. And here's the module. So this is the Bluetooth module. So I have a small button over here, so I hope you guys can see that. So that is for pairing. So I have the antenna over here for the Bluetooth module, and then I'm using a cap over here just to filter noise as well. So it's super ugly. Of course, it's not gonna be there. I'm also thinking about I will explain a few, but I was using a CPRD to test another board besides this one. So, but I decided to use this because just performing a few configurations on the jumpers. So this one is able to understand the codification for the I2S, kind of I2S. So it's not 100% standard, but it's kind of I2S protocol. But this one recognizes it as soon as you perform a configuration with the jumpers over here, right? So it's connected using the wires over here, but just just for the prototype. So in here is the board, right? So the DAC board that I'm using, right? But in fact, so I was researching with a few boards, and I will show you guys. So I made this with those, this one as well, and yeah, I think I do have another one, but I don't know what is it. But the thing is that those are a lot cheaper, right? So and those have better, those have quality as well. So I've been using this for Raspberry Pis and Arduinos and ESP32s. So super good ones, but it has a drawback. The problem is that if you go to the, let me show you guys this, and you will understand that. So where is the OBS? Okay, it's over here. So if you see this, so this is basically how the Yamaha chip talks to the DAC. And you see I have a beat clock that defines the height of the bits that will be transferred. And this is a kind of strange configuration because it has a window of 24 bits, but it uses just 16 bits, and it's aligned with the right. So the standard protocol uses 16 bits or 24 bits, it doesn't matter, but usually it's aligned on the left, right? So, but this one is aligned on the right. It's just right. They call that right justified. And because of that, some DACs do not talk to this, right? So I mean, some more expensive ones understand that and deal with that. So that is the board that I'm using. So it's a bit more expensive than the smaller ones that I'm showing previously, but that is because I'm using that one that it's a bit more expensive. It's not that expensive, but it's better, right? So those ones are cheaper ones. This one works as well, super expensive. I mean, the DAC is super high quality. And this one also, it's intermediate one. So it costs like $3. This one, you can find, depending on the quantity, that amount you buy. So you can find it $2 up to $6 depending on the vendor. But I tried all those, and this one, for example, also works, but it needs CPRD to just get the 24 bits and realign those, and then provide it with 16 bits aligned to the left, right? So I did some prototyping with this and my protocol analyzer, and I do have the code on Quartus over here. So let me show you guys this. This one. This is what you need to do. So you basically need to convert from 24 to 16 bits, and you kind of shift in 8 bits and get the 16, and just perform this on CPRD. And then if you connect the CPRD, you can use that one as well. But the thing is that if I use a CPRD plus the cheap board over here, it's going to be more expensive than use that one. So that is a better option for us. I think it is. I just want to provide you a quick overview and a quick update on the project. So next steps are, you see that I made a profile to, use this one over here. But unfortunately, I can't because this one depends on the CPLD, and we are not going to use the CPLD anymore. And now I need to create a new profile for the bigger one. I'm thinking about using it over here. I think if I do that, so the Bluetooth module can go up there, and I'll have a better organization on the board, and it's be able to include it on the card. On the box, right? So the card box. So that's it. See you soon. Bye.